Okay, day 2 of angles and angle measure, or what I'm calling radians and degrees. As we talked about before, I'm not going to be here for the next week or week and a half, right? This is probably the Thursday or Friday. And I told you that we would do, when we finished the questions that we did on the worksheet, I told you we'd come back and we'd finish all the rest of them. And then you want to submit this today, okay? So the plan today is to finish the assignment that we started earlier in the week. I know on Wednesday we worked on college placement test stuff, and actually next week that's all we're going to do is college placement stuff. But I wanted to finish this idea up. I covered everything pretty much the first time. You probably noticed we kind of skipped questions going through. And the reason we skipped questions going through is I wanted to kind of cover all of the ideas so that today this would be like kind of the second day on it, right? And hopefully goes smoothly in terms of understanding what's going on here. What is a little weird, what was weird, and this may not be, it'll make sense to you, and it strikes me as being weird, but it's not that weird. But I'm doing this lesson right now, and it's Friday, February 26th, right? This is like, I did this video 2 weeks ago. Well, I'm doing it right now here, but like you're watching it 2 weeks later. And you might not say, okay, that makes sense because you had to make all the videotapes of all the stuff before you were going to be out for your surgery, right? But what's weird is I'm not sure, like I presented this on Monday or Tuesday, depending on whether you were period 3 or period 5, but I'm doing the second lesson before I did the first lesson. And so I'm not 100% sure what I'm going to say in the first lesson, right? So I have to, like, I can't say, well, I know I said this. I'm assuming, a lot of times I'm going to say, well, I probably said this on Monday or Tuesday, so we already knew this. And I'm hoping I did, right? So it's just okay, I mean, I know how to teach the material, so I'm pretty sure I know what I'm going to say. But it's weird. I'm going to be anticipating now what I'm going to say in the future, and then you guys are going to watch this video. I know it's all like a time warp thing, right? It's just weird. Like, time is a weird thing, right? Anyways, so we're in this thing called it's called I'm calling it degrees and radians. I think that's the name of that's the name of the assignment. And you only submit it once, and you're going to submit it after today, after we finish it, right? I'm assuming I told you when we started that don't submit it because you're going to finish it up this week, right? So degrees and radians. The name of the actual worksheet is angles and angle measure. Because degrees and radians are just two different ways to measure the angle, right? Angles and angle measure is the name of the worksheet. Angles and angle measure is the name of the worksheet. The name of the assignment, I'm pretty sure, I think I called it degrees and radians. Matter of fact, I don't think I've actually made the assignment yet. Like, I don't think it's actually in the computer. Like, I don't think I've made this into a PDF and uploaded it yet. Because I wanted to get the lesson done first. Anyway, so we're doing now. Again, just a reminder of what I hopefully talked about in the first lesson was in the first half of this homework assignment is that as you go around the circle, or go around what we call the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. When you make a loop around a circle, it's 300. We say it's 360 degrees. So it starts at 0. So what's weird, and this is important, and this plays a really big, what's that? Oh, it's on the camera. Oh, I was trying to erase something that was actually on the camera, or on my iPad. Oh, now I erased the measure. So anyways, measure. I can't spell. What's important is you can keep going around, right? So we could also call this 720, because that would be 300 plus 300. And again, you can go backwards too, right? You could actually do your arrows going this way, so you could actually call it negative 360 or negative 720. And one of the things that's important to grasp philosophically, it's not really hard pragmatically, is that there's an infinite number of ways to describe any angle. An infinite number of ways to describe any angle. You can call that 0, you can call it 360, you can call it 720. You can even go around a third time. I don't happen to know what 360 times 3 is off the top of my head. Let me just figure it out on the calculator. 360 times 3. 1080. It can be called 1080. You can go 4 times around the circle. Where the angle ends up is called the terminal angle. Now, what we try to do is we try to put it between 0 and 360 so that we don't get all confused, right, when we're doing this. But we want to realize that it's what's called the wrapping function, right? That we can keep going around as many times as we want, or we can go backwards as many times as we want. And what we want to be able to do, and this is what gets, this is why it's kind of important, is this can eventually lead to this idea of waves, of sine waves and cosine waves. The idea that it goes out to infinity, and that we can start thinking of these waves that get generated by looping around and around and around, like a tire. Imagine like a tire going down the street, right? And then every time it goes around, it hits that little. Let's say there's a little tiny nail in the tire, but not enough to make it flat. It would go around and around and around, and so every so often it would hit the ground, right? So there's this idea that when you have an angle, it can be like an infinite number of solutions, of which we generally try to put it in the first quadrant, and we generally try to put it in the first in the first loop around, right? Well, that's actually the first quadrant, so in other words, it could be in any of the 4 quadrants, and there's certain marks here we have to realize that are kind of going to be important to us in terms of figuring stuff out. The truth is, for each one of those, there's an infinite number of possibilities too, right? Like a gazillion different possibilities, right? You can go here and call it 90. You can go around again and call it 90 plus 360 would be 450. You could actually go backwards and call that negative 270, right? And it's not that we do it a lot, but we do it enough that you have to be cognizant of the fact that you can go backwards or forwards, and there are an infinite number of places to do it. So again, if I were to have an angle here, let's call it 30 degrees, you have to be aware that I'm measuring it that way. Now, what if I went around? And that's kind of how we symbolize it, right? That would be 390. And these are the same. In every way on that picture, they are the same. Okay? But they wouldn't be if we were extending it out into the sine wave. It would be technically different, but all the values would be the same, right? So there's an infinite number of ways, and we could go backwards. We could actually go backwards. What if we measure this way? Around. Then we call that negative 330 degrees. So one of the things you have to realize is that angles, you can go around the circle in the positive way, you can go around the circle in the negative way, and you can go around and around and around and around and around and around and around, right? But in general, we try to say, okay, even if we do something spastic, like go around like 12 times and something like that, or we call this, whatever, how many times we went around, 390. We always want to kind of be able to think of it, okay, yeah, we're calling it 390 for some reason of which might come up, but really it's the same as 30. In other words, every time you get an angle, you want to be able to move that angle back to somewhere between 0 and 360 if you can. But then what we realized is, hey, degrees is really just arbitrary. The Greeks just decided to break the circle up into 360 parts. Why? Why? Why is once around 360 degrees? Well, because it's about how long it takes the Earth to go around the sun. But it's not exactly that long, right? Because 360 is just divisible by a whole crap load of numbers, right? You can divide it by 2 and 3 and 4 and 5 and 6 and 8 and 9 and 10 and 12 and 15. The Greeks didn't have calculators and stuff, so they said, well, how should we break the circle up when we go around? And so they just decided on 360. So that's completely arbitrary, right? So as we advanced in mathematics, we realized, well, we need a better way of doing this so this doesn't seem so arbitrary. Now, here's the thing. For most of you, you will hate radians because it's not intuitive. It's not intuitive, okay? And the reason it's not intuitive is because pi messes it up. It just messes it up miserably, okay? But we don't have any choice, okay? So here's the deal. What we're gonna do is when we have degree measure, we're gonna do this thing called radian measure. So when you go around a circle in radians, we're gonna do it on what's called the unit circle. We're gonna do it on this thing called the unit circle. And we know the circumference of a circle, right? Back from grammar school, right? We know, just digression here. Let me digress in green here. The circumference is 2 pi r. So when you go around the circle here, depending on what the radius is, it's going to be 2 pi r. But what we do in math is we just say, hey, since angles are the same no matter what the radius is, right? It doesn't matter how big or small I make the circle. That angle is still going to be whatever. It doesn't matter if I make a little tiny circle or make a really, really big circle. But this angle here is going to be, it's going to be the same regardless of the size. So as math people said, well, if that doesn't matter, then what the heck? Let's just make R1. So what we do is we make the radius 1, and that's what's called the unit circle. We're going to make the radius 1. And so then if that's 1, then the circumference is exactly 2 pi, and then that's how far it is around the circle. So there's this correlation then, and this is obviously a big deal, is that 360 degrees is the same as 2 pi. And then we've talked about that, right? That's kind of where we left off on the worksheet last time, is we were converting from one system to the other. Like if we had a degree, make it a radian by knowing this, what we call conversion factor. That's not how we're going to actually do it, but that is the conversion factor. So anyways, if you go all the way around the circle, it's 2 pi, right? And again, there's certain numbers that become kind of important to us then. Let me switch to green, to red, so I think it'll show up better on the video. You could go backwards, so it could also be called negative 2 pi. In the same way that could be called negative 360. You could go around twice, and that would be 4 pi. You could go around 3 times, that would be 6 pi. You can go around 8 times, and you get my point, right? There's like an infinite number of things that we could call it. So that's called radian measure. There's certain numbers that we want to know. Like if it's 2 pi all the way around, then halfway around would be pi. And then if you go a quarter of the way around, that would be pi over 2. And if you go 3/4 the way around, 3 pi over 2. That one sometimes freaks kids out. That's 1.5 pi, right? So every quarter way around the circle is half of a pi, right? Because if all the way around is 2 pi, then halfway around would be pi, but half, and then if I only go a quarter of the way, which would be half of half, that would be pi over 2. So every time I go around, I'm adding a half of a pi. So half of a pi, full pi, 1.5 pi, 2 pi. And those are kind of important things because they actually tell us when we switch to another quadrant, right? So we break the circle up like that into radians and degrees. So that's the thing. Now, we could get into a whole discussion here that the Greeks messed this up really badly, and they did, okay? But we don't have a choice. This is called radian measure, okay? This is called radian measure. This is radians, and of course, this is called degree measure. When we switched from degrees to radians, that was considered a major upgrade in how we think about measuring a circle, going around a circle. There was a major problem with this. This is all bad, right? The reason it's bad is that, I'm going to digress here, and this has nothing to do with, we have to do it this way, but I'd feel bad if I didn't mention this. This is a major, human beings really screwed up here, big time. Yeah. I'm gonna just gonna talk about this just for a few minutes in this box. This has nothing to do with what we're gonna be doing because we're gonna be doing radians. We screwed up. Human beings screwed up when they did this. When you go around a circle, the circumference divided by the diameter is how we get pi, right? And so the circumference is pi times diameter, and so then you, but then we change it. The diameter is 2 radiuses, so that's where we get the 2 pi r from, right? The definition of pi is you measure the circumference, and you might have done that in grammar school, right? Where your teacher might have had you take a string and go around a frisbee and measure the length, and then lay it down, and then take a ruler and measure the length of the frisbee, the circumference, and then you measure the diameter. You get a ruler and measure the diameter of the frisbee, and then they might have had to do it like different types of things, like maybe the top of a tuna can or something like that. Different circles, and you do this where you found the circumference and you divide it by the diameter, and every time you did it, you got 3.14. But then here's the dumbass thing about this, right? And we changed the formula to radius. That messed everything up, right? Because the fundamental thing that makes up a circle is this radius, right? You got my thing, go around. That's how you make the circle. Is you have a center, you have a radius, and you can go around. What human beings did wrong back then, and we just, for some reason, we refuse to fix it, is we should have done, instead of dividing by the diameter, you guys, we should have just divided by the radius anyway, since that's what we wanted, right? We want the formula in radius. And here's the thing. Stay with me here. If we did circumference divided by the radius, that's called tau. That's called tau. What would be so cool if we had done that, then when we did our formula, circumference would be tau, so then the circumference would be tau r, which would be so cool, right? So, and you might, Mr. Peters, why is that cool? It's super duper cool, okay? Because then, if you went around one time, it would be 1 tau, not 2 pi. So then halfway would be half tau. A quarter of the way would be quarter tau. 3/4 of the way would be 3/4 tau. And the world would make sense, right? It would make much more sense if you went around the circle once, you could say 1 tau. If you go around the circle twice, 2 tau, right? It would just make more sense, okay? But sadly, we're stuck with this. because you know how human beings are, and they don't like the change. We've been using radians. Radian was good enough for my dad, good enough for my grandpa, good enough for my great-grandmother. It's good enough for me, okay? So we're gonna use radians, even though it's sucky, okay? Radians makes all of math sucky, okay? All of trig sucky. If you've done any pre-calc or trig before in your life, and when you've done radians, that's what makes it ugly. But we're stuck with it, so we have to do it. Anyways, I just want to make sure you realize I was editorializing there. That's my opinion. There are mathematicians that think that radians is the perfectly good way to do things. They're just wrong. Well, again, in my opinion. Okay, so let's start now looking at, so this is the idea. We have these two forms of measurement. Once around the circle is either 360 degrees, or once around the circle is 2 pi, and then we can break it up into whatever size we want, like 30 degrees, or 210 degrees, or 240 degrees, or 312 degrees, whatever we want, right? And then we just got to kind of estimate where that is. So here's the deal. The first set of questions we're going to do here is based on, in the questions 3 to 10, we're going to be what's called converting. So now we're going to start working on the homework, okay? 3 to 10, there's this called conversion factor. So here's what you do. Since 2 pi is the same as 360, what we're going to say is, well, that would mean pi would be the same as 180. Just dividing by 2. That just makes the conversion factor go more smoothly. So here's what we do. If I have a degree and I want to change it to a radian, I'm going to multiply it by pi over 180. If I have a radian and I want to change it to degrees, I'm going to multiply it by 180 over pi. Now, think about what's happening here. If you've had chemistry, you know these things called conversion factors. It's kind of like changing an inch to a yard. So you'd multiply by 360 or divide by 360, 36, depending on what you want to do. Or if you wanted to change an inch to a foot, you would multiply by 12 or divide by 12, depending on which way you were going, right? Stuff like that. Remember, these are equal. What do we know if you take something and divide it by itself? If you take something and divide it by itself, it's 1. And you are allowed to multiply by 1 and not change the answer. Well, we are changing the answer because we're changing it. Why? Because pi is in radians and that's in degrees. So what's happening is the degree symbol cancels in terms of the unit, and now we get the radian. And vice versa here. If this is radian measure, by the pi, it represents the radian measure, so I'm canceling out the radian units, and then I'm multiplying by the degree units. So I'm changing units. Again, very similar to like if I had 4 feet and I wanted to change the inches, I would multiply it by 12 inches over 1 foot, technically, right? We just multiply by 12 in our head, but what we're actually doing is multiplying by 12 inches divided by 1 foot, and then the feet cancel out, right, unit-wise. And you do this a lot in chemistry too, right, as well as physics, is changing units. So this is it, guys. This is our little Bible. Make sure you write that down, right, because you got to know that for the test. Now, you'd have to memorize it, but if we were in school, but you're at home, so just write it down. This is what we're going to do. This is what we're going to do to answer the questions. So number 3, what if I have negative 4 pi over 3? Feel free to break out a calculator on these. I tend to not use a calculator, but don't feel like, oh, Mr. Peters, I don't know, I can't, I don't use a calculator when I do these, but it would be perfectly okay to use a calculator. So what you want to do here is you want to, when you see the pi, that means it's in radians. And so if I want to convert it to degrees, I'm going to be using that formula here, right? I've got a radian, so the formula says take 180 over pi. Now, what will happen here, of course, is the pi units cancel, and that's what we want, right? We want, the pi kind of represents radian measure. It represents radian measure. And then now I have degrees. And then I'm going to cancel the 3 into 180 60 times. And then negative 4 times 60 is 120. So, and again, remember the negative there? That represents something, doesn't it? That represents going in the negative direction. That represents going in the negative direction. Oh crap! Except that you guys, oh my God. What's 40 times 60? If you're like, Mr. Peters, you screwed up, you're right, I did. This is bad. Wrong. Negative 240. 4 times 60 isn't 120, it's 240. My bad. Okay, and then we're going to do a few of these. Remember, we're filling in all the ones we didn't do. So if I'm starting there with 3, that means hopefully, remember I'm doing this in the future, hopefully I did 1 and 2 already, right? So now you're going to be completing the worksheet, right? So hopefully we did 1 and 2 already. Hold on, I need a piece of paper here. I got this little piece of paper here. These are the ones that I'm planning on doing in class on the first day, and then here are the ones that I'm planning to do today. I made my list a little shorter today, so hopefully it won't take us as long as to get through the homework as it would on the first day. Of course, you already know that because you won't be watching this till afterwards. Again, that's also weird. Okay, so anyway, so the next one we want to do to complete the assignment is 4. Number 4 is, again, you sometimes get these really weird looking fractions, right, when you're doing radians, which tends to annoy students in the first place. And one of the things we'll talk about, as you stay in math and go on in math, if you do go on in math, you'll tend to leave things in radians. But the first year or so you're doing radians and degrees, if you're like me, you're always converting everything to degrees because you just want to do the question in degrees because you want it to match what you've done in the past, which is okay. And you can get by doing that in this class. It's like, I would call it running around your backhand in tennis. You can do it for a while, but at some point you've got to learn the radians. Right now we're just introducing them, so don't panic. Like, oh, that's a weird number. Like, where is that on the where is that if you graphed it? I don't know. Well, actually, I do know, but it's really close to being 360, right? Why do I know that? Because it's almost 24. And if it was 24, it would be 2 pi, and I know that goes all the way around. So I know this is really deep into quadrant 4, right? But again, I've been doing this for 30 years, right? Okay, so here it's in radians, and I want degrees again. So I'm going to use the same formula. So I want to take 223 pi. And these two questions are kind of nice next to each other. They kind of illustrate, like, that one wasn't so bad, but this next one might be a little tougher. And again, we have this, what we call a conversion factor. This converts radians to degrees and degrees to radians. So now let's see if I can do the math right on this one here. The pi's cancel. 12 goes into there 15 times. Now again, if you don't know that, don't worry, just break out the calculator, okay? And then like right now, I'm gonna break out the calculator for 23. I mean, I know it's 345, but that's because I've done this a million times. But I'm just taking out the calculator now. So if I want to do this on the calculator, I can say 180 divided by 12 is 15. And then I'm going to do 15 times 23 is 345. Now, something I'm hoping I mentioned this last week, but I'm just going to say it in case I didn't. Kind of important here. You want to make sure you put degree symbols on, because technically if you don't, you probably noticed that when you use Google, technically if you don't put the degree symbol on, is technically supposed to be considered a radian in terms of math grammar. Don't worry about it. I'm not going to penalize that. If it doesn't have pi, for us, because this is not totally true, but for us, if it doesn't have pi, it's probably a degree. If it has pi, it's probably a radian. In theory, you could actually have pi's and degrees, and you can have radians without pi's. But for this class, we'll try to delineate by pi and no pi. But that's not really totally true, so I want to make sure I'm clear about that. So if you're wondering why I keep making sure I put a degree symbol on, is because in theory, the pi can be in the degree and may not be in the radian. But for us, we don't have to worry about that right now. Okay. Remember, we're just this is just introduction to radian measure and a review of degree measure, right? Okay. So I move on down here. Now, we can't see that, so you're going to have to make sure you have that written down. What am I referring to? Make sure you got our little conversion factor, because we're not quite done with that group. We still have 2 more to do. Number 8. So again, this is the first set of questions, 3 through 10. Actually, it's actually 1 through 10. I apologize. It's 1. No, hold on. Let me go back here. This is 1 through 10. Now, we did some of them. We did a bunch of them in class. I'm just doing the ones that we didn't do, okay? Just to remind us of this. So again, this is hopefully just a review of what we did on Monday or Tuesday, right? 6. See what I did there? I said what we did earlier in the week, Monday or Tuesday, which is really actually from my perspective, like in the future, a couple of weeks. Still freaked out by that. Okay, so number 6. -3, 15. Well, we're switching gears here a little bit. That's a degree, and we want to change it to a radian. That's a degree, and we want to change it to a radian. Okay? So, instead of 180 over pi, we're going to do the other way around. Pi over 180. And again, you want to try to reduce that. Now, technically, this is correct. Notice that you get rid of the degree symbols then. That's technically correct. But what you want to do on this one here is you want to reduce the fraction if you can. So if we divide by 5, so I'm going to get out the calculator to help me out. 315 divided by 5 is 63. And 180. And now, why did I pick 5? Because it looked right to me. I noticed, it ended in 5 and 0, so I knew it was 5. Now I got 63 and 36. So the next one's going to be, what, 9? 9. 63 divided by 9 is 7. Pi over 4. Now, again, don't panic on that. Just do your best to reduce it, okay? Some people are better at reducing than others. I want it reduced all the way if you can. But like if it's a 5-point question, you'd only miss like 1 point for not reducing the whole way. And then the last one of this type, I'm going to try to fit it in here. Number 8. No, we have 2 more to do, 8 and 10. So we have 2 more left to do. So actually, yeah, let me just try to fit it in here. 5 pi over 4. So 5 pi over 4, we have this rule that we do 180 over pi. And you probably figured this out. If there's a pi at the top, make sure there's a pi in the bottom so it cancels. So then that cancels. And then 4 goes into there 45 times. Again, if that's not obvious to you, then break out the calculator. 180 divided by 4, and you can get the 45 that way. Okay? And then 5 times 45 is 225. So we're converting this radian to a degree. We're converting that radian to a degree measure, right? And then last one, 3 pi over 2. 3 pi over 2. And again, so we're doing 3, 5, 6, 8, and 10. That means hopefully I did 1, 2. No, we did 3, 4, 6, 8, and 10. So that hopefully means I did 1, 2, 5, 6, 7, and 9 earlier. Cross your fingers, right? Actually, you'll know whether we did that or not. I don't know at this point in time. My plan is that we'll have covered all 10 of these questions then. 3 pi over 2. Again, 180 over pi. 9, 2 goes into 18 9 times, but it's actually 180, so that's 90. 3 times 90 is 270. And of course the pi's cancel. And again, you don't, if you forget it, don't worry about it, but technically you want to make sure you got a degree symbol on there since we're switching from radians to degrees. Again, if you want, you can take 3 times 90 and divide by 2 and put it in your calculator. But the main thing is make sure you cancel those pi's off before you haul off and start reducing it. Okay, so that's the first set of questions. Now we want to do, now I'm gonna skip 11 through 16. We're gonna come back to them. I just think the worksheet is better done in a different order. I probably gave a long explanation of that on the first day because I did them out of order on the first day pretty severely, okay? We did not start with the conversions. We started with degrees. Here's the problem, and I'm probably repeating myself. The book, the worksheet, and whenever you start a calculus, a trig discussion about this, whether it's pre-calc or whatever, they weirdly make the assumption that you don't know degrees or radians and they're equal to you, which is completely insane, right? Because you've had degrees your whole life and radians is really the new thing in your environment, right? So, but it's weird, like almost all pre-calc books, when they introduce the topic, they say, hey, we have 2 ways of measuring things, degrees and radians, as if you've never seen either of them or you've seen both of them. They treat them like equally, which is like crazy, right? Because degrees you've known, you've had degrees ever since you were a kid, but radian is what's new. So that's why I'm doing things a little out of order, okay? So just to be clear about that. So now, the next set of questions I want to work on are 20, 22, and 24. Now we did the degree ones. This is new, but it requires what we just did. So let me write these. The next group I want to work on is what I would call the 17 to 22 questions. The 17 to 22 questions. And I want to do 20 and I want to do 22, okay? We did all the rest of these already. We did 17, 18, 19, and 20. No, we don't want to do 22, we want to do 21, right? Yeah, we want to do 21. Sorry, you guys, you already did 22. Well, you haven't done it yet, but you'll have done it before you see this, right? So what am I getting at? This group here, 17, 18, 19, 20, 21, 22. We did all the degree ones already. Now we're going to do the radian ones. Number 20 is 11 pi over 6. And number 21 is negative 10 pi over 3. Now, here's the deal. If you can graph it without changing it to degrees, that's incredible, okay? I have calc students that can't graph these without they couldn't do this. Even AP Calc students. In other words, in theory, you should know that this is right here. But let's talk about why it's there, okay? And then in theory, here, this would be right about here. Okay. And you should just be done. You should be able to look at it, just do it, just like we did the degree ones. But let's face it, degree and radians, degree is the one we know right now, right? Eventually, you should be able to know that that's where that angle is. But how do I actually do this? I/6 times 180. So notice what I'm going to do. I'm going to do what I just did to change it to degrees so I can get a handle on it, right? So I can get a handle on it. So the pi's cancel. 6 goes into 180 30 times. So I get 11 times 30, which is 330 degrees. So that is where it is. 330 degrees, almost 360, but more than 270. Okay. Now, why did I do that? Hopefully we talked about this. I'm not real picky about how accurate it is. It's got to be in the right quadrant, right? In other words, I'm not going to get out a ruler and say, oh, did you make it exactly 330 degrees around? What I'm going to be focusing on is you have the arrow in the right quadrant, right? Like if you had it down here, that probably wouldn't be right, but I wouldn't mark it wrong, right? It's not. I'm just like, hey, did they know about where that angle goes? It does not have to be perfect. If you can do it based on radians, that's awesome. But most people, when they on their second day and doing radians, they can't. So the way you get it is we call running around our backhand. We change the radian to degree because that we know how to do. And again, we practiced those ones already. Negative 10 pi over 3, same thing. What we're going to do is we're going to convert it 180 over pi. Now, this one has another thing. It's negative, right? Because that's kind of sucky, but we can deal with that, right? So 60, negative 600. Something that, remember I said earlier, we should be able to measure negative 600, but many people can't, and don't worry about it. Just keep adding 360 till you get a positive, right? So I'm going to add 720. Now you might be saying, why 720? Because I know if I add 360, it won't work. Positive 120. So notice I'm going to convert it to 120 degrees, which is more than 90 degrees, but less than 180. Again, I'm not going to break out a ruler and make sure it's exactly 120. It's just got to be in the right quadrant. And then there's two questions at the very end where you just have to state the quadrant. It's really the same question. It's literally the same question, except you don't have to graph it. But I'm going to treat it like like that. So technically, 23 and 24 it's a different question, but it's really not. It's really the same question. Negative 5 pi over 6. What I'm going to do is I'm going to graph it, just like I did the other one, just because I think it's a smart thing to do in this question. Because it said, what quadrant are you in? Again, it's negative, so you got to be a little careful here. When you do this. So it's 180 over pi. Cancel out the pi's. Cancel that in 30. Negative 150. Now, again, I've been doing some of this math pretty quickly, but don't worry, you could just do it in your calculator. So I'm going to add 360. If I add 360, I get 210. And I know 210 is right here. It's more than 180, but less than 270. So, but you guys, you're not supposed to draw the picture. You're just supposed to say it's in quadrant 3. I would accept the picture though, as long as the picture's in the right quadrant. Okay. You don't have to actually draw the picture for this one. You just have to know it's in quadrant 3. But I think it's a good idea to do that, right? Okay. Now, what's left here? Okay, so we've done 3, 4, 8, 10. That was converting. And then we did 20, 21, and 24. And then we just have 12, 14, and 15. I've obviously run out of space in this board, so let me grab the markers and let's move over to the front board to finish up this assignment. Again, in theory, if I did things right, and again, we won't know until the future comes whether I did this right or not, we should now be done with all of the questions. Well, once we do the 12, 14, and 15. 12. Now, these get into some pretty crazy stuff, right? I save these for last because students sometimes find these the most challenging. 12. We're told that that is pi over 6. What's the other one? 14. I kind of want to have you see all of them when I start here, right? 14. What if I go backwards like that? Hold on. Let me take that out for a second. Here, I want to add it in a second. I want to change colors here, though. And then I want to put this in a different color here. I say these for last because these are the most challenging ones, in my opinion. And then the last one. So 12, 14, and 15. We did all of the degree ones already. Okay. We did, oh, crazy. Oh, man, this is an insane one. This one's like, we're going to go what? Go around once. And then they give us the angle here. And they give us this angle here. Is 5 pi over 12. Okay, so the question is what is this angle? So 12's not that bad. They get progressively more challenging, right? Why? That one's not bad because it stays in the less than one time around. This starts to loop around once. That starts to loop around a couple times, it looks like. Well, not quite twice. But that was going negative, too. So how do you do this? Well, the first thing you want to do is, and again, later on in your life, if you stay on in math, you don't want to do this. But for right now, probably want to convert it to degrees so you can get a better handle on it, right? So 180, remember the rule for that is 180 over pi, so the pi's cancel. And then 6 goes into 180 30 times. Now again, if it takes you a little longer to do the math on that than me, that's okay. But just make sure you realize it's 30 degrees. So what do I know if it's halfway? I know if it's halfway, it's 180. So what I'm going to say is if I went all the way to here, it would be 180. But that is 30. So that angle, this angle I called it X, would have to be 150. Would have to be 150. Now, technically, you should have to change that back to radians, but I'm not going to make you do that. You can change. You can say, Mr. Peters, I'm changing the question in degrees. I'm going to give my answer in degrees instead on these three because I think they're a little more challenging. If you did that, what would you do? 150 pi over 180. Cancel the zeros. 180 and are divisible by 3. 5 pi over 6. The actual answer is 5 pi over 6, but I'm comfortable with you writing 150 since they're equal to each other, right? 150 is the same as 5 pi over 6. Okay, I'm going to go backwards. Whoa, let's use a different color though. one full loop. So I know that's at least 360. So what I really need is this last little piece here. So it's going to be 360 plus this little bit, right? Pi over 3 times 180 over pi. So we're going to cancel the pi's. 60. Now remember, this is 90 degrees here, right? So, sorry, this is 60, I apologize. Pi over 3 is 60. This is 90 degrees here, right? So if that's 60, this has to be 30. So one time around is 360 plus 30 more. 390. And like I said, I'm okay if you want to leave it like that. I'm okay if you want to leave it like that. And then the last one, and then we're done with the whole thing. Let's see what we got here. One time around, two times around, so that's going to be 720, right? 360 plus 360. But then I need this last piece. Let me put this in green. I need this last piece here. Well, I know the green piece plus the red piece add up to 180. I know the green piece and the red piece add up to 180. What I need is, what is that? So let me convert that, and then we'll be done. 5 pi over 12 times 180 over pi. The pi's cancel. 12 goes into there 15 times. 15 times 5 is 75. Now again, some of you might take a little longer than me to do that, but 75. So if that's 75, and I know the whole way, if I went the whole way is 180, so I'm going to take 180 minus 75, which is 105. So this green angle is 105. This green angle is 105. So 105. Oh, not 150. Sorry. Oops. There's my dyslexia. 105. So what's that? 835 degrees. Pretty crazy question. Pretty crazy question. I would never ask one that tough. I probably, to be honest with you guys, I'll probably leave these in degrees if I choose to put these ones on the test. These ones I ended with because they're a little bit beyond what I think we want to be able to do. The ones on the first board are the ones that I would put on a test regarding the radians. I will put these ones on in degrees, but we will have done those. Those are like questions 17, 18, 19, and 22, which we already did on Monday or Tuesday. Okay, that's it. Make sure that you submit the assignment. Now you should have it complete. All the questions should be done here. And let me get out of the way just in case you're, let me back up just a little bit. Just a reminder that next week we're going to be focused. So we're gonna shelve the trig till I can be back in class. Okay, until I'm healthy enough to be back with you guys. We're gonna shelve it, and I'm gonna do some college placement stuff. Remember, I wanted to do at least 2, maybe 3 college placement tests. We're gonna try to finish the second one. Now, I'm sure I mentioned this already, but I wanted to put you guys at the same pace as the college prep. So we started with 16 on Wednesday. So you should have done 16, 17, 18, and 19 on Wednesday. That was one assignment. And then I'm gonna break it up into 3 more assignments next week. So the 3 days next week, you will not have any new material. We'll just be doing 3 5-point assignments on college placement. Anyways, I will talk to you guys soon. Hopefully I will be back in a couple weeks, and everything will be back to normal. Cross fingers, there's a chance that we might even be on campus, but the next time I'm actually back with you live might actually be in person. We might be doing that hybrid thingy, which I have no idea how I'm going to do that either, so but we'll figure it out. I'll figure it out, don't worry. But anyways, I will see you guys soon, okay? Bye-bye.